Hi, I'm James Crampton, Chief Rocket Scientist here at Rocketry Works. I'm here to tell you today about how to build our second prototype Luna model rocket system. So this rocket kit is designed to be built in about 15 minutes in a classroom setting. I'm going to go through it today with you in about 5 minutes because it's really that simple. There's no glue, no tools, and it's really ready to go right at the end of this video. And I'm actually going to go out and do a test flight today just to make sure our parts are working right. We have a new design here based on product design work by Hurdler Studios in Vancouver, Canada. We're looking forward to seeing this in flight and getting it going. So let me show you how simple it is. Here we go, taking a look at the second prototype of the Luna model rocket kit. Let's take a look at what's in the bag. So we start out with a 12-inch long, 24mm high gloss white tube. It's pearlescent in finish, so you really don't need to paint this or really do anything to it, but it will take markings from a Sharpie marker. Also in the bag, the other main component is a fin can. This is plastic molded, and it is a one-piece motor mount and fin can, really designed to simplify this build process. We have a nose cone for going on the top of the rocket and helping this rocket cut through the air smoothly, and a line of Kevlar shock cord, which is fire resistant line that is going to help us hold the back end of the rocket onto the front end of the rocket and help us deploy our streamer, which is a Mylar streamer 2 inches wide. Also in the box are Rocketry Works stickers that are going to help us build the rocket and snazz up the rocket some if you want. And now at this point in our prototyping stage, we are missing a motor retainer, and that will be essential for making sure our motor stays in the rocket when we're done with the thrust phase, so that when the ejection charge comes to pop the nose cone off, our motor stays in place. It happens that currently it's so tight in there right now that the friction fit is going to keep it in nicely, but we're working on that for the next iteration of this. So for right now, let me start out by showing you how simple it is. You may start your clock. The way you start is you take your line of Kevlar thread, and so again, this is flame-proof thread that's going to hold the parts of the rocket together. I'm going to pass it through from one side of the motor mount to the other, so that when I pass it back through over the top, I've got a loop in here that I can hang my fin can from. I'm going to do a simple overhand knot with a doubled up line. So I double up the line in a loop and take that and pass it back through just the way we came, and then tighten those up. So with that knot, we're able to hold this on here, no worries. I'm going to pass this through the middle here. So that's going to be shooting right up toward the top. So next step, take the other end of that shock cord, pass it all the way through the airframe body. Now this is pretty stiff cord, so it goes in pretty easily. It's not like pushing a snake up a hill. Basically, you then take this from the front end of the fin can and kind of twist it and slide it down. Keep pulling that string taut so that it doesn't get tangled there. And once you're on that motor mount, you're going to slide it all the way to the back. You see these little tabs here. When that motor is inserted, it's going to force those tabs out, and they have little teeth to dig into the sides of the airframe tube. So when that happens, slide it all the way in. When you insert your motor here, it's going to create a friction fit that is not going to give up. So at that point, you have your whole airframe body assembled, and we're ready to proceed to connect it to the nose cone. So again, you take the loose end of your Kevlar thread and tie 3 overhand knots to secure that to the nose cone. There's a little cross piece right here. You can thread it right through the little grooves in that nose cone and tie it off. 3 times will have a good chance of making sure that does not go anywhere. Pull that a little bit and it's good. Now the final component here, now that we've got our airframe connected to our nose cone, is we lay down our streamer and we take one of our Rocketry Works stickers and lay it right across that shock cord. So that is now connected to our streamer, which we're going to ball up and hold inside the rocket during flight. But when the ejection charge blows that nose cone off, this streamer is going to pop right out and provide an aerodynamic brake that'll slow the fall of this rocket so that it is recovered safely, ready to be flown again. Now what I've done here is I kind of folded it in half just to kind of minimize the amount of time I spend rolling, and in the end I wind up with a roll that I'm able to insert into my body tube. You can slide it in a little further and make sure the rest of that shock cord goes in. I don't have any loose ends hanging out, and with that the rocket is fully assembled. We can use these other stickers to decorate the side, or you can mark it with Sharpie marker, or really it was designed entirely to look great just sitting right like this, ready to go. At this point, our next steps in the flight preparation process would be to insert our model rocket motor. You see my shock cord is kind of dangling out the back. That's okay. That's going to go back up in there. So we'd insert the model rocket motor, and then with the motor retainer that has yet to go on there, we would secure that model rocket motor inside the aft end of the airframe, and that would be ready to go. You'd then add the igniter and the igniter plug, and the fuel system is ready to go. You would then pull out your streamer and shock cord, insert recovery wadding or dog barf. For those of you unfamiliar with dog barf, it is cellulose housing insulation that is treated to be flame resistant. It's much cheaper than recovery wadding. We do sell it at rocketryworks.com. You can get a whole gallon of it for like under $1. So it's very inexpensive. It's a little bit messy though, so if you're likely to be doing rocket prep inside a room, I'd really recommend recovery wadding, which we also sell at Rocketry Works. It is a little more expensive, but it doesn't come with the mess of that fibrous cellulose insulation. In any case, get your recovery wadding in there because you want to protect this streamer from the hot ejection gases that are going to blow the nose cone off at the end of flight. And again, to fold the streamer, fold it up a couple times so that we don't spend all our time rolling, and then we sort of take a little bit of that roll and roll it about as wide as a pencil. So when you get done with that, you're going to have a roll that's a little fatter than that. You slide it into the tube and it's out of your way. It's protected by the recovery wadding in the tube and ready to fly. So there you go. That is the full build of the Rocketry Works Luna model rocket. It's a great kit for classrooms and other school groups, or scout groups, 4-H groups, or any community group that you may be working with. Alright, have a great time out there, and I'll catch you on the other side.